Hello, hello. We are back with Chapter 10, Probability, focusing on Lesson 6, Probability of Independent and Dependent Events. So we're going to be focusing on two different types of probability today. Events are independent when the outcome of one event has no effect on the outcome of the second event. Events are independent when the outcome of one event has no effect on the outcome of the second event. One example of this would be rolling a number cube and flipping a coin. Those are independent events. So if I have a number cube here and I'm flipping it, and I also have a coin, if I flip a tails, that has nothing to do with how this cube or what it does. Or if I roll the cube and I flip the coin, they have no effect on each other. I mean, they're totally independent of each other. So these would be, if I did both of these at the same time, these would be considered independent events. Okay? Independent. Oh, independent. Okay, cool. So, find the probability of rolling a 4 and flipping heads. So, we want to first look at, to figure a problem out like that, how many outcomes are there for the number cube? Well, the number cube has 6 different outcomes, right? So we're going to say there are 6 outcomes for the number cube, and how many outcomes are there for the coin? Well, there's a heads or there's a tails. So there's 2 outcomes for the coin. So using the fundamental counting principle, there are a total of, remember, if we can just take these 2 numbers, so the number of outcomes for the cube are 6, and the number of outcomes for the coin are 2, and so we can just multiply those together and we get 12. So there's 12 possible outcomes of rolling a number cube and flipping a coin. Now this is really, really important to figure out, because when we figure out the probability, this number right here, the number of possible outcomes right here, like whenever we're finding probability, there's always a number on the bottom. Well, the possible outcomes, the total possible outcomes, that's the number you put on the bottom of the fraction, okay? And then, so that's really, really crucial, because the fundamental counting principle helps you find, it's a really quick way of finding the total possible outcomes. So another way to do it, which isn't as quick, but is to make a tree diagram of the possible outcomes. So that's what we'll do. So let's just start with heads or tails, okay? So let's talk about heads. Let's say we flip a heads or we flip a tails. Those are the only 2 options with the coin. Now, if we flip a heads, we could also roll a 1, we could roll a 2, a 3, a 4, a 5, or a 6. Right? So we could go heads 1. That would be 1 outcome. We could go heads, flip a heads, roll a 2. Flip a heads, roll a 3. Flip a heads, roll a 4. Flip a heads, roll a 5. Flip a heads, roll a 6. Or for tails, if we flip a tails first, we could roll a 1, 2, 3, 4, 5, 6. So that means we'd flip a tails first, roll a 1, flip a tails, roll a 2, flip a tails, roll a 3, flip a tails, roll a 4, flip a tails, roll a 5, flip a tails, roll a 6. Okay? So those are all of the possible outcomes. Let's see if we have 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes. These are all the 12 outcomes listed. Now, of these 12, how many ways are there of rolling a 4? Oh, sorry. How many ways are there of rolling a 4 and flipping a heads? So when we're looking at this, flipping a heads is right here, rolling a 4. There's only 1 outcome, and it's right here. Okay? So when we're finding the probability, the total possible outcomes is on the bottom, but the favorable outcomes are on the top. Okay, and this is favorable. So how many possible ways are there of rolling a 4 and flipping a heads? Well, there's only one. There's only one outcome where that works. So what we're going to do is we're going to find the probability of flipping a 4 and heads. So the number of ways, this is favorable on top. Number of ways 4 and heads can occur. Well, there's only one. And number of possible outcomes, that is our 12 right there. That's our number on the bottom. So the probability of all this happening is 1/12. Okay, it's only going to happen 1 out of the 12 times. Okay, perfect. So that is independent. These two things have no effect on each other, flipping a coin or rolling a cube. Okay, let's go on to the next example. Go ahead and flip your page. The next thing we're going to talk about are dependent events. So events are dependent. Events are dependent when the outcome of one event does have an effect on the outcome of the next event. They're dependent. They're dependent on each other. Events are dependent when the outcome of one event does have an effect on the outcome of the next event. So, for instance, drawing 2 marbles in a row from a bag without replacing the first marble are dependent events. So, let's say we have some different, let's say, we have some different marbles. Remember, this is Minecraft now. They're Minecraft marbles. Okay, so what right now would be the probability of picking a green? So the probability of picking a green would be the number of favorable. Well, there's 2 favorable, right? So I'm going to go up here. I'm going to say the probability of picking a green would be 2. There's 2 greens out of a total of 1, 2, 3, 4, 5. Okay, so let's say randomly we do pick a green. Okay, so we pick a green, and then we want to say, well, what happens? What's the probability of picking 2 greens? Well, if I pick the first green, it's 2 out of 5. But what's the probability of picking another green? Well, now the probability of picking another green is a little bit different, because how many favorable are there? There's 1 out of 1, 2, 3, 4. So it's dependent, because it's just dependent. So if you want to find the probability of picking 2 greens, you take these probabilities and you'd multiply them together. And so you can always look to cross cancel, right? The 2's would cancel out. 2 goes into 2 one time, 2 goes into 4 2 times, and then you multiply across. 1 times 1 is 1, 5 times 2 is 10. So the probability of picking a green and then another green is equal to 1/10. Okay, that is the probability. And that would be something that would be dependent. Okay, now something that would be independent would be picking a green and then putting the green back and then picking another green. Okay, so that would be independent, because you put the green back. But once you pick a green and then that green stays out, the next pick is dependent on what we did previously. The probability changes. So that's kind of the idea of dependent. Okay, so let's look at this example. It says a bag contains 3 blue and 5 red marbles. So we have 3 blue, 1, 2, 3, and 5 red marbles. 1, 2, 3, 4, 5. Okay, find the probability of drawing 2 blue marbles in a row without replacing the first marble. Okay, so what is the probability of drawing 2 marbles in a row, 2 blue marbles in a row. Okay, so let's look at this. That's the key, without replacing. When we see without replacing the first marble, we know that we're dealing with something that is a dependent event. Those are the key words. Without replacing the first marble. Boom. We're talking about dependent. All right, cool. So let's look at this. The total number of marbles in the bag is, so we have to find that, the total number of outcomes. So we can just count them. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 8. Or we can just look at the problem and go 3 plus 5 is 8. Now, how many blue marbles are there? Well, there's 1, 2, 3. There's 3 blue marbles in the bag. So the probability on our first, if we're randomly picking these and they're all mixed up, right? So the probability on the first draw would be the number of favorable. Well, there's 3 blue ones, so that means that there are 3 favorable out of the total, and there's a total of 8. Okay, so that's the probability of picking on the first draw is 3 8s. Okay, let's say that we randomly pick out a blue, right? Now there are how many marbles in the bag? Now it's a different amount. 1, 2, 3, 4, 5, 6, 7. There's 1 less because we took out that blue marble. So now we only have 7 marbles in the bag. And then if you drew a blue marble on the first draw, there are now only 2 blue marbles left in the bag. So that means that the probability for a blue marble on the second draw, now there's only 2 favorable out of a total of 1, 2, 3, 4, 5, 6, 7. Okay, so this is the probability for the first draw. This is the probability for the second draw. Now this is kind of cool because if you want to find the probability of picking 2 blues, what you do is you take the probability, so probability of a blue and blue, you take the probability of the blue on the first draw and you multiply it by the probability of the blue on the second draw. So the probability of the blue on the first draw is 3 8. And you're going to multiply that by the probability on the second draw, which is 2 7. So here we are, back to our fractions. We look to cross cancel first, right? Whenever we're multiplying fractions, you always look to cross cancel. So can't do anything with the 3 and 7, but the 2 and the 8 we can. There's a common factor of 2. 2 goes into 2 1 time, and 2 goes into 8 4 times. And now we can just multiply across. 3 times 1 is 3, and 4 times 7 is 28. We would look to simplify that, but at this point, I'm pretty sure that that is simplified. So that means that the probability of picking a blue and then another blue is equal to 3 28ths. So that's pretty cool. So we're going back and using that fundamental counting rule, okay? And that we talked about 2 different types of probabilities, independent and dependent. So, yeah. All right, we'll see you next time.